Refraction of waves. By the end of this lesson, you should be able to describe refraction of waves in terms of the angle of incidence, angle of refraction, wavelength, frequency, speed, and direction of propagation. Draw a diagram to show refraction of waves. In deep sea regions, the water waves take the shape of plane waves. This is because the depths of the water are almost the same. As the waves approach the shore, they bend according to the shape of the shoreline. Why do you think this happens? What happens to waves as they propagate in different depths of water? A square glass slab is placed in the ripple tank so as to create different depths of water. What can you say about the wavelengths of the waves as the waves propagate in different depths of water? When waves propagate from the deep to the shallow regions, the wavelength decreases. As the waves are continuously produced by the same source, the frequency of the waves remains constant. The speed of the waves equals the frequency multiplied by the wavelength. Since frequency is kept constant while the wavelength decreases, then the speed of the waves will also decrease. The speed of the waves depends on the depth of water. The ripples slow down as they pass through shallow water regions. This causes the wavelength to decrease. After the waves have passed through the shallow water regions and back into the deep water regions, the wavelength increases. As the waves propagate from the shallow to the deep water regions, the wavelength increases. What can you say about the direction of the waves as they propagate in different depths of water? As waves propagate at an angle to water of different depths, there is a change in direction of the waves. When waves propagate from water of different depths, there is a change in wavelength, speed, and direction of the waves. The change in direction is due to the change in the speed of the waves. This phenomenon is called refraction. What happens to the light waves as they enter the water? Click on the Start button. The light waves bend as they enter the water. As light waves propagate from one medium to another, the waves are refracted. Why does this happen? As light waves move through mediums of different optical densities, the speed of the waves changes. This will result in a different wave direction. Have you ever been on a camping trip? Notice that during the day, you can see other campers on the other side of a field, but you cannot hear their voices. However, their voices can be heard during the night. Why does this happen? The speed of sound waves is faster in warm air than in cool air. This is because warm air is less dense than cool air. During the day, the layers of air near the surface of the earth are warmer. This causes sound waves to be refracted away from the earth. During the night, the layers of air near the earth is cooler. This causes sound waves to be refracted towards the earth. This explains why voices in different camps can be heard clearer at night. Draw a boundary line to separate deep and shallow regions. Label the regions. Draw a line to represent the direction of propagation of incident waves. Mark with an arrow. Label O at the point where this line meets the boundary. Draw the normal at point O. From point O, draw a line to represent the direction of propagation of refracted waves. Mark with an arrow. When waves propagate from deep to shallow regions, the refracted waves bend towards the normal.
Draw the normal at point P. From point P, draw a line to represent the direction of propagation of refracted waves. When waves propagate from the shallow to the deep regions, the refracted wave bends away from the normal. Mark with an arrow.
Draw parallel lines which are perpendicular to the direction of propagation of incident and refracted waves. These lines represent the wave fronts. Make sure that the wavelength in the deep regions is bigger than the wavelength in the shallow regions. Label the incident angle I and refracted angle R. The angles are measured from the normal to the incident and refracted waves. You are now going to draw the refracted wave patterns for water waves moving over a convex-shaped glass slab. Complete the diagram by showing the passage of water waves from regions of different depths. Draw the wave patterns in the activity sheet. What can you say about the refracted waves? The refracted water waves seem to go towards a focus point F after passing over the shallow regions of the water above the glass slab.